Cadê? Pra cá tá ruim.
Attempt to hide her from his jealous wife, Hera. Wow, so the cow did jump over the moon? Oh, I think we could use some more cowbell. Okay, enough of the cows. Back to space. A neutron star gets born after a supernova collapses. After birth, it rotates extremely fast, about 60 times per second. But this rate can sometimes grow up to 600 times per second. Makes me dizzy. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light everything up around? You don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. Another one of Saturn's moons, Iapetus, has a unique two-tone coloring. The difference between the satellite's two hemispheres is impressive. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. All of the planets of the solar system would fit between Earth and the Moon with some space left. Yes, there's lots of space in space. Saturn isn't the only planet that has rings. Gas giants Uranus, Neptune, and Jupiter have rings of their own, but they are thin and almost impossible to see. NASA can convert plasma waves, radio waves, and magnetic fields into audio tracks and listen to what's happening in space. They record all kinds of intriguing sounds, from beeps to ambulance-like howls. At the same time, space itself is an eerily silent place. There are some sound waves and vibrations, but people can't perceive them. The star's core takes up to 25% of its entire radius. Inside, gravitational forces create incredible temperatures and pressure, which makes hydrogen fuse into helium. This layer has a temperature of 27 million degrees Fahrenheit, give or take. All that energy moves to a zone called radiative. It takes on average 170,000 years for the energy to get all the way from the core to the next convective zone. There, bubbles of hot plasma float upward and end up at the sun's surface. That's where a visible 300-mile thick layer starts. This gassy zone, and don't I know about gas, is called the photosphere. It gets heated to 10,000 degrees and consists of granules, cells of plasma 600 miles in diameter each. Moving further, we get to the crown. That's the star's thin atmosphere. It's getting hotter again, with temperatures reaching 3.5 million degrees. So we'd better not linger. The smallest of all the 4 inner planets, Mercury is just 3,000 miles at the equator. It's also the second densest planet, topped only by Earth. Mercury has a massive metallic core. It takes up almost 85% of the planet's volume. Its core contains more iron than any other planet of the solar system. Recently, it's been discovered Mercury might have a solid inner core, along with its outer core that consists of liquid metal. The planet's outer shell is composed of a rocky mantle and solid crust, which is just 250 miles thick. Mercury is too small to hold onto its atmosphere, made up of hydrogen and helium. The planet is also too close to the sun. That's why the solar winds keep sweeping away the little atmosphere the planet manages to gather. Our next stop is the hottest planet in the solar system, with average temperatures reaching 870 degrees Fahrenheit. It means lead would melt if you brought it to Venus. The pressure on the planet's surface is the same as at a depth of 3,000 feet underwater on Earth. The planet's metallic iron core is 2,400 miles wide, which is almost as the distance from New York to Los Angeles. The next layer is a molten rocky mantle that's 1,200 miles thick. Venus's insides are covered with a crust. It consists mostly of basalt and is 6 to 12 miles wide. The planet's thick atmosphere is nightmarish. It's 96% of carbon dioxide with 3% of nitrogen and thick clouds of sulfuric acid. Now, on Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish-red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the Sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique system of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in Earth's oceans. It's one of the oldest, largest, and at more than 12 billion light-years away, it's the farthest known to humankind. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because Kelt 9b orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? You wouldn't? Okay. One moon day is equal to about 29 days on Earth. It takes that long for the sun to cross the lunar sky. People always see the same side of the moon. The Earth's gravitational field makes the moon spin around its axis slower. That's why it takes the moon the same time to rotate around its axis as to orbit around the Earth. It was only in 1959 that people could finally see the other side of the moon, thanks to a photo taken by the Russian spacecraft Luna 3. The other side of the moon is more mountainous than the one we see from Earth. It can be explained by the Earth's gravity, which made the crust on the visible side of the moon thinner. Craters on the moon were left by asteroids 4.1 to 3.8 billion years ago. They're still visible only because geological changes on the moon aren't as active as on Earth. The winds on Neptune reach the speeds of 1,600 miles per hour. That's 3 times.
All right, ladies and gentlemen, our video has ended. So far, so good. Any question?
Hello, say.
Yes, please.
Please, why is Venus the hottest planet, though Mercury is the closest to the sun? I just want to.
Okay, why is Venus the hottest planet, right?
Yeah.
Okay. You see, take it this way. White surfaces reflect heat or reflect light, but black surfaces absorbs it. Now, Venus surface actually keep whatever heat it gets. So even though Mercury is the closest to the sun, but Mercury reflects more of the heat it gets back. But on Venus, Venus is the second closest to the sun. Venus gets the heat and keeps it. So it makes it the most hottest among all the planets, even though Mercury is the closest to the sun. Are you okay?
Okay. Yes,
Okay,
please, I am. Thank you.
okay, that's fine. All right, any question again? Okay, so your recordings are ready. I'll forward everything in your Slack channel together with the learning materials, the learning site you can be reading. Okay, now we can dig through and start our whole thing. We have 7 minutes to end the class, but before that, I'll quickly take you through something before our next meeting, which will actually introduce us to each of the planets, their characteristics, their various activities they do. Then we watch another video. Remember, every time we have a class, we will watch a video. This video satisfy your curiosity in space. At the end of this program, you should be filled, satisfied with everything in space. And after that, if you want to pursue the space exploration, or you want to become an astronaut, you can pursue in astrology, astronomy, and go your way. Right. In our solar system, that's in this our solar system, the Milky Way, we have planets in them, and the planets can be grouped into two types. So, as we know, we have these 8 planets. They are also grouped into two types. One, the type 1 are called terrestrial planets, and the type 2 is called gas giants. What are terrestrial planets? When we say something or a planet is a terrestrial planet, meaning it has a solid surface whereby you can stand on it. For example, Earth is a terrestrial planet. You can actually stand on it. We have a solid surface on Earth where you can actually stand on it. Gas giants, their planet is filled of only gas. There is no way you can stand on that planet. Whenever you attempt to stand on it, you will fall within that gas giant. For example, initially when we were starting, I made it clear to you that the superior or the almighty Jupiter is a gas giant, and it's also called planet eater or asteroid eater. Whoever comes closer to it, it will eat you, or it will bring it will bring you into it. Note, every planet has its gravity. The bigger the planet, the higher the gravity. Now, Jupiter has the highest gravity, meaning the highest pulling rate. It can pull a whole lot of things to itself. When you get very closer to Jupiter, it will actually pull you into it. Millions or billions years ago, it started eating asteroids because it's a gas giant and it will just bring you inside. Now, the space agency NASA has predicted that Jupiter is getting closer. It's getting closer to Earth. And so, if there should be a way we should do, or we should do to avoid we getting closer to Jupiter, we should start very early, because when we get too closer to Jupiter, Jupiter will eat Earth. Any asteroids, for example, let me show you an asteroid for those, sake of those who just joined. This is an asteroid. This is an asteroid. Yeah. So any asteroid that gets closer to this gas giant This is the gas giant, Jupiter. Jupiter. This is Jupiter. And you can even see it is constantly moving. The surface is constantly moving. A storm, a gas giant in a shape or in an oval shape. Gas giants keeps on eating planets, anything that comes closer. It has the highest gravity. Let's go. Planets that are orbits. Okay. Planets that orbit other stars are referred to as exoplanets. Now, as a space exploration student, you should note something here. We have exoplanets. These are planets that are not found in our solar system. These planets are also in another galaxy that's also orbiting a giant star. For example, their sun. They also have their sun there, but it's not called sun. Those planets are called exoplanets. They are not in our galaxy, that's the Milky Way. With the exception of Uranus and Neptune, each of these planets can be seen unaided. All 8 planets can be seen through the use of inexpensive amateur telescope or binoculars. All right, when you go to space, I don't know, even some of you wants to visit space one day. Whenever you go to space, then yeah, for sure you'll be going to the ISS. You go to space, there is a telescope there that aids in viewing these planets. But with exception of Uranus and Neptune, these are very close to impossible because you need extra powerful telescope. Let's take Mercury. Mercury, as we all know, is the smallest and the fastest planet. The smaller the planet, know this, the faster it orbits. And know planet, each planet has its own orbits around the sun. How can a planet orbit, or what moves a planet? Like, ask yourself that question. Does the planet has an engine that moves it, or what's actually moving that planet and setting that planet on a particular course that it doesn't crash with other planets, or it doesn't get out of this galaxy to enter another galaxy, or it doesn't fall? What is actually pushing this planet or keeping it in space? Well, this is not magic. As a space exploration student, you should understand that every planet in a galaxy is pulled by the highest star. In this case, in our Milky Way galaxy, our highest star, biggest star is the sun. Now, the sun, remember I told you, the larger the object, the larger its gravity. Now, the sun is the highest and the biggest object in our solar system and the brightest, meaning its gravity is more than any other object in our solar system. Now, its gravity is having impact on all the planets in the solar system, in our solar system, all the planets in our galaxy. The sun gives Mercury gravity. So the sun is pulling Mercury each day, each night on a particular path. So that spinning of a planet is pushed by the gravity of a sun. Any questions so far? All right, ladies and gentlemen, our time is up. I'll just take 5 minutes. 5 minutes. Now let's move to. Okay, and we know Mercury is also the closest to the sun and whips around it every 88 Earth days. So our Our Earth goes round the sun using 365 days. Now, Mercury revolves around the sun. That's a year for us. A year on Mercury is 88 days on Earth. Please take note of it. During our program, we'll be having tests and quizzes to test our knowledge to improve ourselves. Take note of these points. Now, Mercury, a year on Mercury is 88 days on this Earth, meaning it takes 88 days for Mercury to complete its whole orbit around the sun. That's day and night, day and night, day and night, day and night, 88 days. So when you compare it to Earth here, so 88 days is about, let me say, 4 months. Probably. No, 4 months is more. 3 months. 3 months is more. So let's say 30 days, 30 days, 30 days. 3 months. It takes 3 months in our perspective, 3 months for Mercury to complete a year on its orbit. It's all pushed by it being faster, and the faster is pushed by it being the smallest. Please, any questions so far? All right, let's move to Venus. Now, this planet is actually the mysterious. It spins in the opposite direction to most planets. So let's say, as every other planet is moving from, let's say, left to right, this particular planet, Venus, this particular planet moves from right to left. Venus is the hottest planet and is one of the brightest objects in the sky. Why is it brightest and why is it hottest? It's hottest, and you will know that automatically if it's the hottest, it's going to be the brightest, because when it takes all these heats, it heats up, it doesn't give. So for Venus is not a giver, it's a taker. It takes and keeps it. So as the more you take, the more it become more hotter, the more it become more brighter. And it's also spin in the opposite direction in our galaxy, that's around the sun. We will know more about Venus in our next meeting and we take it from there. I will send you this page or the link to this page for you to read more. Our next meeting, we will dive into the various planets, the number of days it takes, why Venus spin in the opposite direction. I'll make you know, or then we move on and we complete our whole program. Ladies and gentlemen, thank you for joining this session. I will send a recording to those who couldn't join this morning. Thank you. Any question? Right, if there are no questions, the class has ended.
Thank you, Seth.
Thank you. You're welcome.